l'intervento di Monsieur Cavalier dell'Association Française du Roi.
Sì, sono qui. No. Buongiorno a tutti. Parlerò in inglese anche. I just have, first of all, to apologize for Patrick Antoine, who was supposed to talk 5 minutes this morning on this issue, but he was unable to come here, so I just replacing him on this issue, and I want to deliver you his message on the French Refrigeration Association position concerning the evolutions of regulation on F-gases mainly. We really think that it is necessary to review the F-gas regulation in Europe, and this is, we think, the first major step for us, and we appreciated the overall objectives given by the proposition of the Commission. We worked a lot on giving inputs on that and to react on the first draft, even if it was a non-draft. And we think that we have to focus in order to have a really good European regulation to reach environmental goals we have. But our main point is that we need to be fair, first of all, and to take into account all the elements. Of course, the direct GWP, but also the energy consumption and the risk assessment of the different solutions, and finally the economic situation of each sector. As you know, we have already implemented in France some elements that are in the project of the Commission. Since '92, we are applying regulation to all kinds of equipments over 2 kilograms of F-gas, for example. We have enlarged it to transport, refrigerated transport, to car air conditioning. So we appreciate all these elements in this sense. But we have also done mistakes, such you have heard about the French regulation on ammonia refrigeration. We nearly banned during years ammonia in France, even if it is environmentally friendly fluid, because of safety issues. And we just want to be careful on the way the risk is taken into account, because please don't do what we have done on ammonia during years at European scale from some solutions. So, in the same time, we have just one small problem. The French government has planned to build a tax on HFCs, an environmental tax on HFCs, and this is our main fight right now, because as European Commission, among the different tools available, has chosen regulation and ban of fluids or reduction of fluids, and this is a coherent project. European Commission has said we don't put a tax in the same time, but French government has an objective to built a 3 billion euros tax on environment per year, and among this tax they have found that it would be very interesting to tax HFCs, and on the different scenarios this tax could bring between 350 million up to 700 million euro per year to the French government. So it's quite interesting, because it's a big part of the 3 billion. But we think that is totally inefficient, because it is just incoherent with F-gas revision at European level. It is a national initiative while we have a European regulation that is on progress. So it's a second weak point. And of course, because on an economic point of view, this money that will be withdrawn from the industry of refrigeration will not be invested in the evolution towards environmentally friendly solution. So we really think that it is not a good solution and a good idea of our government to build a tax on F-gases, and our fight right now is for French Refrigeration Association is to say no to a tax. that would be environmentally not friendly and not efficient. So if you want to support the French position, you can help us to convince our government that the idea of a tax on HFCs is not the right time, not the right place, and not the right solution. So this is, at the moment, our position of F-gas evolution. Yes to a European evolution of F-gas in the frame we have seen, with an integration of the three main drivers: energy efficiency, direct impact, and risk assessment, but also economic drivers, and not to a supplementary tax, of course, at a national level. Thank you very much for your attention.
Gerard Cavalier, direttore del Cemafroid, che è un organismo che si occupa di certificazione con svariati diversi laboratori, parlerà degli F-gas nei trasporti refrigerati, situazione e prospettive.
Buongiorno. Sì, abbiamo parlato molto dei gas. Vorrei parlare dell'evoluzione nel trasporto, dell'impact della F-gas. I will speak in English. It will be better, and the transparency are in English also. Cemafroid is a French competent authority for transport refrigeration in France. We are doing the tests in the laboratories and the certification of equipment also. We have a lot of data concerning these equipment, and it's why we have made this study on what is the situation regarding refrigeration in transport with F-gases, and what are the perspectives for the future in terms of replacement. So I will present the situation of the fleet in the world, in Europe, and context, and the situation of refrigeration in transport regarding F-gases use, and then the challenges we have to face. Just the fleets, according to the AirTalk report of 2010, roughly 4 million equipments are in service for transport refrigeration in the world, for terrestrial transport, and some 5 up to 8,000 reefer containers. That is an average of terrestrial equipment for one equipment for 1,700 inhabitants, but this is very different from one country to another in the world. In Europe, we can evaluate in the 27 countries of European Union to 1.1 million equipments, and that is to say one for 450 people. It's a little bit less in China, and even lesser for India, according to NCCD data from 2012, with one equipment for 200,000 people. The market in the developed countries is a mature market where we are renewing the fleet, and roughly the average duration of one equipment is some 10 years, 9 to 10 years, and 10 to 12% of the fleet is renewed each year in Europe in transport. The main changes of the fleet and equipment are due to the evolution of the use of the equipment. The main challenges faced by transport is urban delivery. Our cities have changed, the habits of people, of consumption have changed also, and urban delivery is really the great challenge of transport, and refrigerated transport, of course, is one of the major ones. Massification in the transport from production to the distribution centers is also a big challenge. Just data in France, in semi-trailers, the average load of fresh products is 10 tons per semi-trailer when the available load is 25. So we have less than 40% of use of this load. And also new products and new sensibility. Health products, for example, are more and more temperature sensitive. Just in 2011, 50% of the new pharmaceutical products introduced in the market in France have to be kept between 2 and 8 degrees. In the developing countries, it's an equipment market, new equipments, and it's an exploding market. China went from some 30,000 equipments in 2007 to 80,000 equipments in 2009. So just the growth rate of the fleet in some countries. The context in the world is that there is a regulation mainly dedicated for performance of insulation and refrigeration capacity in Europe, large Europe, because now ATP area, the agreement on perishable transport, is gathering 49 countries. The last country we join is Turkey. And F-gas is not in application in all countries. In France, for example, F-gas is mandatory also for transport, but it should apply, as we have seen in the revision. Also, other regulations are impacting refrigeration in transport, is eco-design, transport regulation, and carbon footprint. In the global footprint of frozen products, for example, you have the graph on the right of the slide. You see that transport, refrigerated transport, is 6% of the total carbon footprint of frozen products we are consuming in Europe. In France, we have, I think by chance, a mandatory regulation for all equipment. That is to say, a high level of quality of this equipment, except for some uses such as short transport and vegetables. And the total fleet is 150,000 equipments. But due to this mandatory regulation, we have a centralized system with all the data concerning the transport equipment, and including the information concerning F-gas are included in this database. And using this database, which includes 300,000 equipments, half of them are still in service, half of them have been withdrawn, we access to detailed information concerning F-gases in transport. And we have made the analysis of these uses of F-gas in transport in detail. First of all, an overview of the French fleet. 52% of the fleet is concerned by vans, less than 3.5 tons. 26%, roughly a quarter, is semi-trailers and trailers, and the 22 least percent is for trucks. Less than 1% are concerned by train equipments and mobile boxes. In this fleet, 96% of the fleet is equipped with air-blown evaporators systems, or the refrigeration technology. Nearly all equipments are using vapor compression systems. And in this compression system, 4% are for eutectic system, but including a refrigeration unit, and 96 other percent are for air-blown evaporators. Concerning the source of energy, 55% of this equipment are motor-driven equipment. That is to say, the engine of the vehicle is driving the compressor directly or indirectly. And 45% are autonomous. That is to say, they have a specific engine, generally a diesel engine, which is driving the compressor of the refrigeration machine. A new kind of equipment appeared in the 90s is a multi-temp equipment. That is to say, in the same truck with the same unit, you manage to have at the same time 2 or 3 different temperatures. Now we have some 25% of the equipments in service are multi-compartment equipment. Most of them are only 2 compartments, but you see that it's quite a common thing. It's a way to improve the environmental efficiency, because you can, in the same truck, deliver 2 different products, such as frozen products and fresh products in the same shop. Concerning the refrigeration machines, you see the spread of refrigeration capacities, and you see that 17% are between 5 and 10 kilowatts, and 30% are over 10 kilowatts, containing the biggest ones. And generally, you have an average here size of the refrigeration machines, but also technology is available. Most of them are vapor compression systems. You see that on the left you have a solid cryogenic system for small containers, for example, very small volumes, generally less than 1 cubic meter, and at the other side appeared in the 70s, but again in the last few years, direct cryogenic systems using liquid, but this is remaining a niche and equipped only some tens of equipment in France. In this table you have the different technologies. We won't go in details through the technology, but you see first that mainly when you withdraw the cryogenic system, solid or liquid ones, you have nearly at least 4 fluids used, but 2 main fluids, that is 134A and 404A, that are mainly used. And in fact, when we analyze F-gas used in transport, 95% in mass of the fluids installed in the French refrigeration system in transport are 404A. So the whole fleet is impacted by the project of F-gas directly if transport is included. 4% is 134A, and less than 1%, less than 0.5% is 410A. But this is not exactly the same in other countries. Nevertheless, roughly we have here the spread of the fluids in the world fleet. You have also the mass of fluids that was installed in the production of 1 year. To say, in 2011 it was 47 tons of fluids and 45 tons of 404A. Some I just mentioned in the eutectic system. They are using also a second fluid in the plates or tubes, and it's a eutectic solution with a freezing point at -35 or -26. And this is a quite important volume, but it is something different. The average load of this unit is 3.86 kilogram per unit. It is quite variable from small units that you have seen is 50% of the market roughly, where you have 1.5, 1.6 kilograms, and the autonomous system for trucks and trailers, where you find roughly 6.5 kilograms per unit. The average load for 1.1 million equipment in Europe is 4,200 tons of HFCs in the transport refrigeration systems, and if we transfer it, it's 16 million tons for CO2 equivalent. So when we have in this situation, what are the solutions for the future, alternatives? This is the evolution. Roughly the vapor compression system for transport refrigeration units has not really changed for 50 or 60 years now. We have still the same conception of the machines. There was no real innovation. We have win in terms of fiability, of time life. The first revision now for the last machine you have in the middle is 3,000 hours before a revision. Before it was far shorter. We have reduced the risk of breakdown of the units on the road and so on. But roughly the techniques are the same. The fleet in the 70s here is already a cryogenic system, direct liquid cryogenic system, equipping the fleet of yogurt distribution. And it's exactly the same as you have under the 2010 system of cryogenic liquids. So no real evolution in the mass market, but tests are ongoing on CO2 equipments. And this is already on a field test for marine transport is already on sale, and for road transport is already on field test. Some absorption, but only for small volume, the blue one on the right, and other tests are really on the research level. The only available technologies are still vapor compression system using CO2, which is the most convenient for the next future, the short term. In conclusion, refrigerated transport will be directly impacted and strongly impacted by the project of F-gas because of the majority of 404A in the equipment. There is already on the market a partial solution, a cryogenic system, for example, but this will remain a niche. It has its place it's a good solution, but not for all kind of application. It will remain a very limited solution. And at medium term, what is announced is 2025 for all kind of equipment is still vapor compression system with CO2 as fluid. And you have example here, the machines that is already sold for marine containers. The challenge is to build an agenda in the reduction of, in the change of, and the withdrawal of 404A that will be compatible with the arrival of this solution, and also the maintenance of the existing solution, because you have things that transport equipments are used during, let's say, roughly 10 years. And another challenge that is quite important in transport also is to prevent the use of counterfeit refrigerants. Already people died repairing marine containers because of the use of counterfeit refrigerants. We have edited an informatory note of IIR on this issue, and now are appearing counterfeit refrigerant with hydrocarbons to replace 134A or R404. And it's also a safety challenge to manage the counterfeit refrigerants. Thank you for your attention.
Grazie Gerard. Ci sono domande su questa presentazione?
On the maintenance ban that you mentioned, if we take the Commission proposal, it was 5 tons CO2 equivalent, so probably some of those transport systems would fall under there. And I can tell you that what is being discussed in Council and Parliament lifts this up to 50 tons, and there's general agreement that that's probably the scope for the maintenance ban, and that excludes most of the transport systems. So I would think that addresses most of your concerns for the maintenance ban.
Okay, thank you. Altre domande?
I have a question for Mr. Cavalier and probably Mr. Coulomb as well. Is the adoption of HFO considered an option or not?
Some tests have been done by the main manufacturers in the world concerning HFOs in the transport refrigeration. Up to now, it's in the list of solutions that are on test, but it is still on the lab. I have only mentioned the solutions that are ready today, and that is to say, we may imagine that within 2020 or 2025, it is possible to generalize this solution to all kinds of equipment. Of course, the retrofit of 404A by other fluids has been also imagined, but it's not simple. It's not only retrofit, so it's a change of equipment. The challenge in transport is that either manufacturers directly turn to new equipment. It's a choice of carrier, for example, would say it publicly, we move to CO2 and we don't want an intermediary solution. And the other alternative is to change to another fluid, but it will be only a first step, because retrofit of transport refrigeration units need a change of a lot of equipment. The major issue of this equipment is that you are working in a limited place, and this is not the same issue for other equipment. But in Europe, the dimension of transport equipment is regulated. And 1 centimeter is 1 centimeter, and it's not easy to change shortly the conception. But what we can say that we have at medium-term reliable solution to remove 404A if we want to do it in transport. Just what is wise to do is to choose the right agenda in order to make it on the the best way in terms of economy, of environment impact, and in terms of durability.
Thank you.
Okay, thank you.